matrix. Matrix, it's a kind of array with numbers, right? Kind of array with numbers where we can refer them in terms of rows, columns. Right? Then we have elements. The numbers in the matrix is called as elements, right? Then we looked upon some aspects of different types of matrix, rows and columns, rectangle, square matrix. Then we talked about a little on the manipulation of matrix, two matrices, how to add two matrices, how to subtract two matrices, how to multiply two matrices, right? So we said that when you multiply, you have to be careful. When you multiply, the number of columns in the first matrix should be equal to the number of rows in the second matrix. When you multiply, that must be there. Then you can produce a new matrix with the number of rows as the first matrix and the number of as the second. Then we did some examples, right? Yesterday I talked about if you multiply two matrices, A into B or B into A, this is not equal. Today, if time permits, we will see there are only one occasion. This is true. That means AB will be equal to BA, only in one occasion. We might say what sort of situation. Today, or maybe next week, or I mean next time, we will do that. Right. With that remarks, we can continue some of the activities of the matrix, some of the operations in the matrix. Already I mentioned about the square matrix. Square matrix right? By definition, what is square matrix? If a matrix A has the size n into n, then A is called as square matrix, right? A is called as square matrix. So we want to have a size n into n. So suppose let's say A11, A12, up to An. Similarly, A21, and so on. Here An1, and so on. Ann. So this is a size of n into n matrix. Oh. This is the size of n into n matrix. Okay. So this is called as square matrix. Okay. In the square matrix, the diagonal contain containing entries. For example, A11, A22, A33, and so on. Ann is called main diagonal. main diagonal. So they are called as main diagonal. For example, if you have a matrix A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A43, A44. So let's say we have a square matrix. This is 4 into 4. This is 4 into 4 square matrix. So we call as A11, A22, A33, A44. This is called as main diagonal. This is called as main diagonal. Okay. Right. All right. Any questions? So in a square matrix, usually we talk about this main diagonal in a square matrix. In a rectangular matrix, we don't talk about this. Right. Let's talk about the other type of matrix. It's called as identity matrix. So this is abbreviation given as IN, identity matrix. A square matrix with ones on the main diagonal and zeros elsewhere is called an identity matrix. Identity matrix. So the main diagonals having ones, elsewhere, that means off diagonals, having zeros. Let's take I2, 2 into 2 matrix is given as 1, 0, 0, 1. Similarly, I3 is given as 1, 0, 0, 0, 1, 0, 0, 0. This is I3. Similarly, we can expand this for IN. 1, 0, 0, 0, 0. Similarly, 0, 1, 0, 0, 0, 0, 1, 0, and so on. Then 0, 0, 0, 1 at the end. So this is N into N matrix. Right? So this is how we indicate the identity matrix. Why identity matrix important is, suppose if I multiply a matrix A with identity matrix, it should be a square matrix identity. That is same as IN into A, which is equal. So this is one of the important matrix. Okay. So A into identity matrix. So identity matrix into A will produce A. Okay. Right. We'll take an example. Suppose, let's say, if you have 3 into 3 matrix, A, A11, A12, A13, A21, A22, A23, A31, A32, A3. If you multiply by I3, this is 1, 0, 0, 0, 1, 0, 0, 0, 1. Right? If you multiply, you can see how it is working. Right. We will take a very simple example to see that evidence. Let's say a matrix 2, minus 3, 4, 8. Identity matrix with 2, I2 is given as 1, 0, 0, 1. Can you find out the value? Right? Let's say another matrix B, 2, 5, 6, 4. Right? Another matrix yesterday, that 0 matrix. All the elements are 0. Can somebody tell me what is A into 0 matrix? Without doing anything, you can say A into 0 matrix is a 0 matrix. Similarly, B into 0 matrix is a B into 0 matrix is a 0 matrix. Right? Similarly, if you multiply 0 matrix with A, that is also 0 matrix. Or if you multiply 0 matrix with B, that is also 0. Right? So that is how we can. For example, you multiply AB, find out the value for AB, find out the value for BA, you can multiply that. Right? What is the AI? AI will be again the same as A. Multiply A into identity matrix. This multiplied by this, then this multiplied by this, and so on. So it will be 2 minus 3, 4, 8. A matrix. Right? Likewise, AB matrix, you can see what is AB matrix. Multiply A with B, you get it. Anyone, what is the value for AB matrix? What are these 4 values? Tell me the 4 values. Multiply AB. Ahmad, what is the answer?
Okay, so give me a minute.
So this is the AB matrix. Do you all get the same value? 22, 22, 56, 52. $56, $52. Anybody getting a different answer when you multiply A into yeah. Is the answer correct?
No, sir.
What is the answer?
Minus 14.
Oh, there's a minus. Yes, yes. I forgot. This is -3, right?
Yes.
All right. Good. Okay. So what is the answer? -14?
Minus 2.
Hmm.
56, 52.
Okay. Right. I was forgetting this as minus because it couldn't appear to me as minus. Okay. Right. So this is AB. So everyone should know how to multiply the matrix, right? Everyone should know how to multiply the matrix. I don't want to go much of that, right? Take an example. Let's say a manufacturer makes radios. Nowadays, radios is not popular. And tape recorders. Nowadays, that is also not popular. During 80s, these radios and tape recorders are the only option that we had. No television either, right? Tape recorders, right? They are producing radios as well as tape recorders. Each product must go through and assemble process and finishing process. So they go through those two processes, assemble process and finishing process, right? The time required in this process, it is given in hours, are presented in matrix A. It is presented in matrix A, right? So the time taken, let's say matrix A, 1, 2, 4, 1.5. So this is for radio. This is tape record. I will put it as here. Tape record. This is for assembly. This is for finishing. Right? Now, these tape records they have the factories in two places, right? One place is Colombo, the other place is Kandy. So this the second matrix, let's say the matrix B, I'll put it as here, matrix B. It is the hourly payment for finishing, for assembling in Kandy and Colombo. So I said they have factories in Kandy and Colombo. So the B matrix represent the hourly payment for Kandy factory and Colombo factory for assembling as well as for finishing. Right, assembling as well as for finishing. Let's say the rates 300, 350. These are just the rates, don't worry about 400, 375. Right? Okay, as an example. Clear? Right, now when you come to right, so this is the first matrix A is giving the time taken, right, for operations, assembling and finishing of radios and tape recorders. The second matrix giving the rate per hour for assembling and finishing both in Kandy factory and Colombo factory. Right, now we could make a product of this, right? Find the product matrix. Find the product matrix A. Find the product matrix A and B and give the practical interpretation of each entry of AB. And give the practical interpretation of each entry of A. So we were asked to interpret that. Right, now I have two matrices, A and B, right? Let's say A matrix is given as 1, 2. I'm repeating, right? 4, 1.5. B matrix is given as 300, 350, 400, 370. We said this is Kandy, this is Colombo, this is assembling, this is finishing, this is again assembling and finishing of radio and tape recorder. All right, I have repeated. Now we want to find out what is AB. Value of AB, right? For example, let's say AB C11, C12, C21, C22. Right? Okay. Right. Now, what is C11? How we can explain C11? That is 1 into 300 plus 2 into 400. How C11 can be explained? By looking at this.
First row into first column.
Yeah. How we can interpret this? C11. The value is there. 1 into 300 plus 2 into 400. It is the total cost. Right? For what? This is the cost for assembling. Isn't it? It is the cost for assembly, and it is the cost for. It is the assembling cost. It is the Can you mute it, Gunatilaka? Assembling cost is this one. This is finishing cost. So we could say where it is. It is located in Kandy, so of radio. So we could say C11 is the total cost, right? Total cost, assembly, and finishing of a radio in time. Can I say like that?
Yes.
Yes, sir.
But yeah. So this is how matrix array will work. C11. C11 is the total cost for a radio, right, to be manufactured in Kandy. What about C12 then? What is C12? Anyone? How we can write?
Total cost of assembling and finishing of radio in Colombo.
Yes. Yeah. Total cost of a radio in color. What is C21? You can find out the values, multiply, right? What is that? So C12, I can say what is C12? C12 is 1 and 2 with 350 and 375. So that is your C1. What is C21? Is 4 and 1.5. What is C12? How we can write?
Total cost of tape recorder in column candy.
That is the total cost for a tape recorder to be manufactured in Candy. Right? The last one. C22. If you calculate the value 4 into 350 plus 1.5 to 375. You can get the value. So how do you interpret that? It is the total cost of tape recorder to be manufactured in color. You see how matrix or matrices could be used to interpret some activities. Any questions? Right. The next one is transpose of a matrix. Transpose of a matrix. We can say transpose, we can indicate like AT. In certain book, it is indicated as AT, simple T. In certain books, it is indicated as a transpose. So doesn't matter whatever the notations that we are using. All are indicating transpose. AT. What is this AT, a transpose? Interchanging rows and columns. Interchanging rows and columns of matrix A. Right? So what do you mean by interchanging columns and rows and columns? Let's say matrix A having a value 2, 3, 4, 6. The A transpose is given as first row become as first column, 2, 3. Second row become as second column, that is 4, 6. Right? For example, if you say matrix A as A11, A12, A13, A21, A22, A23. Right? So this become, right, when it is A transpose, it's become A11, A12, A13. Okay? A21, A22, A23. So that is the principle. Rows become columns, columns become rows. So in other terms, if you look at the element, Aij will be equal to, in a transpose matrix, Bji. Right? Aij is equal Bji. Right? Right. Let's say A matrix 2, 3, 4, 5, 6, 7, 8, 9, 10. Write down the transpose of this. What is the transpose of this? That is 2, 3, 4, 5, 6, 7, 8, 9, 10. Now multiply A with A transpose. I will give you 5 minutes. Multiply A with transpose. Anybody got the answer? What is the answer? First row,
So 29,
uh,
21,
what is the first value?
21,
Is it 29 or 21? So this row has to multiply with that. What is that?
29.
4 plus 9 plus 16. 29, isn't it? Right, 29. Then this
56,
row multiplied by this column. What is that?
56,
56.
Yes, 56. Then,
83,
okay. Then we have this row multiplied by this. What is that?
56,
56.
110,
Huh?
110,
Okay.
164,
What about this?
83,
Mm.
164, 245,
160?
45,
Huh? What is this value?
That is 164.
What about this? That value.
Same here. Both are 160.
164. This is also 164, right?
Yes, yes.
Right. What is the last value?
245.
45,
200?
45,
200.
Right. Right. Can you observe something here? How do you call this value? First of all, this is a square matrix or not? Is it a square matrix or not?
Yes, it is.
square matrix,
Yes, square matrix, right? Okay. How do you call in a square matrix of these value? Already I mentioned.
Diagonal.
main diagonal,
Main diagonal. Yes. So that is main diagonal. Look at the off diagonal. Off diagonal means above the main diagonal and below the main diagonal. You see a similarity. How we will write the notation for this? Notation C 2.
2, 1.
2, 1.
How do we write notation for this?
C,
C
1,
C
1,
1.
2. How do we write notation this?
C, 1, 3.
How about this?
C, 3, 1.
Right. Now you see C 1 3 is same as the 3 1. Do you all agree?
Yes.
Similarly, C 1 2 is same as C sorry 2 1 and so on. Right? So this kind of nature is called as symmetric matrix. symmetric matrix. That means a square matrix A is symmetric if Aij is same as Aji. Then we call it as it is a symmetric matrix. Right? So when you multiply A with A transpose, right, it will produce a symmetric matrix. Right? A into A transpose will produce a symmetric matrix. So, a matrix C, right, which is symmetric. Right? Aij and so. So if you take an example, right, let's say a matrix A, 2, 5, 6, 7, a simple one. So A transpose is 2, 5, 6, 7. So if you multiply A with A transpose, what is the answer? $29, right? 12, 35, 47. So this is 47. Yeah. And this one, 85. So you see, this is a main diagonal. Off diagonals are symmetric. So this is symmetric. Can you find out A dash A? Because A into A dash means the first matrix is A. All right. So what is A dash into A? A dash into A. Tell me the values. I will give the first element. What is the second element? Third element?
52.
52, yes. Fourth element?
74.
Yes. So you see, that is also symmetric. It is a symmetric matrix. That is also symmetric matrix. So later we will see how about A dash into A, not same as A into A dash. In certain cases, this is true. We will see that later. In certain cases, only in exceptional cases, it is true. Right? So A into A dash, not same as A dash into A in general. Right? So, however, this A into A dash is a symmetric matrix. Any questions? So that is called as symmetric matrix, right? Yeah.
Sir, excuse me.
Mm.
So how to identify the main diagonals?
In a main diagonal, mean how to identify me? In a matrix, this is the main diagonals. Let's say in a matrix, if you say the element, right? A11 is a diagonal. A22 is a diagonal. A33 is a diagonal. So these are main diagonals. A11, A22, A33, up to ANN. So these are main diagonals. So the position of the row and the position of the column are equal. Isn't it? Position of the row and the position of the column are equal. For example, this is, how do we say this? A11, isn't it? AOCO11. How about this one? Right? C22. So the column and the row digits are same. Those are the main diagonals. Clear?
Yes, sir. Thank you, sir.
Right. Right. We'll move further. Very important very important section of matrix. It's called as determinant. Determinants. By definition, for each n into n matrix, there is an associated number called determinant of the matrix. Denoted by determinant of A is given as, this is how we write. Right. So for each n into n matrix, how do you understand? I mean, what do you mean by n into n matrix? What sort of matrix is that?
Square matrix.
Square matrix.
Right. So we can find out the determinant for square matrix. Right. So it should be a square matrix. For a square matrix, there is an associated number, which we call as determinant. So that has been indicated as how to find out, we will see. Suppose, let's say, determinant of 2 into 2 matrix. Determinant of 2 into 2 matrix. Suppose, let's say, a matrix, so square matrix A11, A12, A21, A2. It's a 2 into 2 matrix, as I said. So the determinant of a given 2 into 2 matrix is actually the determinant of A11, A12, A21, A2. So that is equal, very simple this one, A11 into A22 minus A12 into, you can write A12 into A2. Okay, so that is called determinant. Suppose, let's say, I have a matrix A 2, 5, 6, 3. So what is the determinant of this? Take the determinant of 2, 5, 6, 3. So if you multiply 3 with 2, 2 into 3 minus 5 into 6. So that is equal 6 minus 30, which is 24 minus 24. This is what we call as a determinant of this matrix. Is it clear? So 2 into 2 matrix. Another example, B. Find out the determinant of this, that is 8, 3, 2, 4. That is equal 32 minus 6, which is equal 26, which is positive. So determinant can have a positive value, a negative value. All right. What about this? Determinant of this. Anyone?
0.
Yeah. This is 5 into 6 minus 3, sorry. 3 into 10 minus 5 into 6. So that is equal to. So determinant can have any value. It can have positive value. It can have a negative value, or even it can have a 0 value. Right? If it is, if the determinant of A is equal to 0, then it is called as singular matrix. It's called as singular matrix. If the value of determinant is 0, then we call it as singular. If determinant of A is not equal to 0, these are called as non-singular matrix. Later we will talk about certain things about this singular and clear? Right. Singular and non-singular matrix. Right. Now we will go for 3 into 3 matrix. Right. Determinant of 3 into 3 matrix. I'll bring the principles A11, A12, A13, A21, A22, A23, A31, A32, A33. Right? The determinant of this is given as, right, A11 into A22, A23, A32, A3. I will explain this. Minus A12 into determinant of A21, A23, A31, A33 plus A13 into determinant of A21, A22, A31, A32. So this is how we find the determinant. Right? Coming back to this component, just I explained. So first, A11. If you take A11, it is the row, first row is the one it belongs, where A11, and first column is the one where A11 belongs. So when you consider A11, knocking off that row and the column, the remaining Sudarshan, Sudarshan,
12 முடிவுன்றதையும் 11 வரையும் சாய்க்காம இருந்துட்டு இதை வெட்டி பிடுங்குற மாதிரி
Sudarshan, உங்க வீட்டு கதையெல்லாம் உங்களுக்கு கேட்குது. Right? So here, when you consider A11, ignore that row and the columns it belongs. So it belongs to first row and the first column. So ignore that. Then get the determinant from, it's called as cofactor. So cofactor of the remaining A22, A23, A32, A33. Minus, right? So when you talk about minus here, so here when you talk about minus, this is considered as plus, this is considered as minus, this is considered as plus. I will talk about that later. All right. So why this plus and minus? For example, A11 at the digits here. A11. What is the addition of digits? A11 at the digits here. 11. Speak up. If you add 1 plus 1,
2.
what is 1 plus 1?
2, sir.
So is it an odd number or even number?
Even number.
Yeah, even numbers you get plus. A12, what is the addition of 1 plus 2?
It's 3, odd number.
Odd number. So it get negative value. So likewise, you can say, can I demarcate like this? Yeah. So later we will come across how this plus and minus comes. Odd number and the even, right? So that is why here, when you start with right, A11, it is a plus value. A12, it's a negative value. You see that negative comes from here, right? Then get the A12 is belongs to this column and this row. Knocking off that rows and columns, we get the cofactor of A21, A23, A31, A33. Right? Then we go for plus A13 because that is a plus here because it is a even number. So A13 multiplied by, you knock off these two rows and columns, sorry, these two columns and rows, which it belongs, then you get the cofactor of A21 into A22, A31, A32. Any questions? We'll take an example and do it. So then once you get it, to solve this, we'll use another column. So that is equal A11 into A22 multiplied by A33 minus A23 multiplied by A32. So that is your first component minus A12 into A21 into A33 minus A23 into A31. The last component plus A13 into A21 into A32 minus A22 into A3. All right? Clear to everyone? Right. Now I will give you a simple form. Evaluate the determinant of A, matrix A. Matrix A have been given as 4, 5, 6, 1, 2, 0, sorry, 1, 2, 3, 0, 0. Can you find out the determinant of this? I'm waiting for your answer. What is the determinant?
Two.
Pardon?
2.
2.
Yes.
Anyone getting a similar value 2?
12.
Huh?
12.
12.
Yes.
Any other value?
21.
Huh? Yeah, because again?
12.
Yeah, 12. Any other value other than this 12 and 2?
18.
Huh?
18.
80. Okay, we will do it anyhow. We will see how far it is.
So not 80, 18.
18. Lovensia, Cruz.
Yes, sir. I got 12.
Okay, Madhavi. Right, we will do it and see. Right, when you want to find out the determinant of A, as we said, O into multiply of cofactor, right, of 2, 3, 0, 4, minus 5 into cofactor of 1, 3, 0, 4, plus 6 into cofactor of 1, 2, 0, 0. Anybody has any doubt on that? Right? Anybody has any doubt on that? Yeah. Right. That is equal 4 into cross multiplied. So 8 minus 0 minus 5 into 4 minus 0 plus 6 into 0 minus 0. Isn't it? So that is equal. This is 32 minus 20 plus 6 into 0 is 0. So the answer would be 12. Answer would be 12. Right. Try this one. Find out the determinant of that.
minus 11.
Minus 11. Any other answer?
Zero, sir.
Huh?
0.
0.
0, sir.
0.
Other than minus 11 and 0.
Minus 24.
Other than these three answers. Right, we will try together. Determinant of A is 1 into 1 into cofactor of 5, 6, 8, minus 2 into cofactor of 4, 6, 7, plus 3 into cofactor of 4, 5, 7, 8. That is equal 1 into 48 minus 45 minus 2 into 42 minus 36 plus 3 into 35 minus 32. So that is equal,
Sir, excuse me.
yeah,
That is
45 minus 48 or 48 minus 45.
yeah, other way around.
48.
Right. So this is, first one is minus 3,
Another one also.
huh?
the other
Another one
one
also same.
Other one also same. This one,
36 minus 42.
yes, 36.
36 minus 42.
Okay. The last one,
32 minus
32 minus 35. 32 minus 35.
so everybody's not sleeping, huh? Everybody's waked up. Yeah, good. Right, minus 3 minus 2 into minus, this is minus 36 minus 42, that is minus 6, plus 3 into here minus 3, isn't it? Right, so if you expand further, minus 3 become plus 12 minus 9. So that is equal, see. So this is a singular matrix. Can you remember earlier I said if the determinant is equal 0, it's called as singular matrix. Singular matrix, right? Here, this is the matrix. Can you find out the determinant of transpose of a matrix? Can you find out of the same matrix? So what is the transpose of given matrix? 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the transpose of matrix. Can you find out? No, we will do it for some other example, right? Here it doesn't work. I will say A is equal, we will find out the matrix 2, 4, 3, 5, 6, 2, 3, 2, 1. Can you find out the determinant? Then we will find out the transpose. First find out the determinant. We'll have a glass of water.
minus 16. Okay.
Anybody found the answer for determinant?
Minus 16.
Once again,
Minus 16.
minus 20.
minus 15.
minus 20, minus other than these two answers. Yeah, let's look at determinant of A is given as 2 into 4 factors of 6, 2, 2, 1 minus 4 into 4 factor of 5, 2, 3, 1 plus 3 into 4 factor of 5, 6, 3, 2. So that is equal 2 into 6 minus 4 into 5 minus 6 plus 3 into 10 minus 18. That is equal 6 minus 4 is 2, so that 4 minus, here we have minus 1 into minus 4 is plus 4. Here we have minus 8 into plus 3 minus 24. So that is equal minus 16. The answer is minus 16. Right, now get the transpose. What is the transpose? 2, 4, 3, 5, 6, 2, 3, 2, 1. Can you find out the determinant of transpose? Can you find out the determinant of transpose? Can you get the answer?
Minus 16.
Did you try or just you are telling?
No, sir, I did previous A transpose, sir. That is equal to 0. That's why I
I gave another answer due to some other reason. Try this.
44.
Yeah. Everyone try.
Sorry, it's same as minus 16.
Okay. We'll try and do it. Right? So
minus 16.
okay. Right. Transpose of, sorry. Determinant of A transpose is given as 2 into 4, 2, 3, 1. Cofactor of 4, 2, 3, 1. Sorry. 6, 2, 2, 1. Right? Minus 5 into 4 factor of 4, 2, 3, 1. Plus 3 into factor of 4, 6, 3, 2. That is equal 2 into 6 minus 4 minus 5 into 4 minus 6 plus 3 into 8 minus 18. So that is equal 4 minus 2, right? Minus 2 into minus 5 is plus 10, isn't it? Here 10 minus 10 into 3 plus 3, which is minus 30. So that is equal 30. I mean minus 30 plus 14 is minus 16. Right. So what we learn from here, determinant of matrix A is same as determinant of A transpose. So we don't change the properties of the determinant. So that is a unique value, you see. Determinant of A is same as determinant of A transpose. Right, let's look at some of the properties. Not much, we will see. Properties of determinants. First one, if a row, it applied to the column also, O column of a matrix, consist entirely of zeros, then its determinant is equal to 0. Right? That means if a particular row or column is entirely 0, right? The determinant of that is equal 0. I have a matrix with element 8, 3, 6, 4, 1, 2, 0, 0, 0. Right? If you find the determinant, you will end up with an answer. Right? You will end up with an answer C. Either it could be a row or it could be a column. Entirely 0. Right? It doesn't matter whether it is a 3 into 3 matrix or 2 into 2 matrix. Any questions? You can try this and get the answer as a homework to get the determinant. The second property, if two rows or columns of a matrix are identical, then the determinant is equal to 0. So that is another thing. Either two rows or two columns are identical. Let's say a matrix A with the element 2, 3, 1. Another set is another row is with the same element 2, 3, 1. Only the difference is the third row. Right? You could say, find out the determinant. Determinant of A is equal 2 into cofactor of 3, 1, 5, 4, minus 3 into cofactor of 2, 1, 1, 4, plus 1 into cofactor of 2, 3, 1, 5. So that is equal 2 into here 12 minus 5 minus 3 into 8 minus 1 plus 10 into minus 3. Okay, so that is equal here 6, sorry, 7, 14
0.
minus, yes, 14 minus 21.
Plus 7.
This is
Plus 7.
plus 7, right, which is equal 0.
0.
right? So that is another character. If there are two identical, either row or column, because here I gave example with row. You can have two identical column and to check it. The third property, interchanging two rows or columns of a matrix changes the sign of the or sign of its determinant. Sign of its determinant. Right? Right. I will take a very simple. Or we can take either of one, doesn't matter. Let's say we'll take a simple one. Right? What is the determinant? That is 16 minus 12, which is 4. Now I'm going to interchange the rows. First row become as second row become as first row. Okay, first row become as second row become as first row. Interchanging only the rows or columns. So now the determinant is 12 minus 16, which is
minus 4.
okay, right? Understood? Right. Next property, you can do it for 3 into 3 matrix also. It takes time, so that is why I shifted to 2 into 2. The next property, multiply a row or column row or column of a matrix by a constant. Let's say I'm multiplying by a constant k, multiply its determinant by k. Right? I'll take a very simple one. Right? Find out the determinant of this. Find out the determinant of that, everyone. We'll have a break along with that. Huh? Okay, we can continue. Have we found the determinant of this? What is the determinant?
39.
39. Right. Now, let's say I have a new matrix, right? I have, let's say, 5, 10, 15, 4, 5, 6, 2, 7, minus 1. Can you tell me what did I do? What is the difference between these two matrices? You could see what is the difference. Second row and third row are same.
Yes.
First row has been multiplied by 5, isn't it? First row has been multiplied by 5. So now find out the determinant. Find out the determinant. Now, determinant of B is equal 5 into 4 factor of 5, 6, 7 minus 1 minus 10 into cofactor of 4, 6, 2 minus 1 plus 15 into cofactor of 4, 5, 2, 7. What is the answer?
Minus 335.
Huh? Minus 335. Hmm?
195.
Hmm?
95.
100?
95.
Yes, this is correct. So this is actually 5 times of the determinant of A. So that is 39 multiplied by 5. So that is the property, right? Okay. Maybe we will see one more property. Adding a multiple, there are so many properties, but we will take only few. Adding a multiple of one row of a matrix to another leaves its determinant unchanged. So adding a multiple of one row of a matrix to another leaves its determinant unchanged. It could be either for rows or columns, right? Take a matrix A 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that. What is the determinant here? What is the determinant here? We already did for this. We said the determinant for this is 0. Isn't it? Right? Now what I am going to do is, I will take out the row number 2, right? And multiply by 2, 4, 5, 6 is the row number 2, multiply by 2. So if you multiply by 2, it is given as 8, 10, and 12. 8, 10, and 12. And add to row 1 to first row. So now my first row reading would be 8 plus 1. 8 plus 1 is 9. 10 plus 2 is 12. 12 plus 3 is 15. The rest is remaining as it is. Second row remain as it is. 4, 5, 6, 7, 8. So this is my new matrix. Can you find out the determinant of new matrix B? Can you find the determinant? Because, right? So here you will show the determinant of A is going to be same as the determinant of B. So that is the next rule. All right. Any questions?
Actually, sir, is there any special name for the matrix which contain 1 as all its elements?
What do you mean by 1 as?
That means the matrix each each places if the value is 1, then is there any special name for that, sir?
Nothing. I mean, you mean something like this?
Yes.
There's no such special name. The matrix with the element, all the elements with 1. For example, later we will come to that. Sometimes you have only one unique element. Sometimes you may have a matrix with, let's say, right? Something like that. 2 values. Maybe matrix with 2 values, matrix with 3 values, matrix with 4 values, and so on, right? So they have some special characters, matrix with 1. I mean, 2 numbers are appearing. So here only 1 number is appearing. Look at another matrix, 1, 2, 1. Let's say 1, 2, let's say 2. Right. This is 1. Just a second. This is 2. Right. So look at this matrix and the matrix here. So here, this matrix is only with one value to every element. Here matrix with 2 values. 1 is also there, 2 is also, right? So this is another matrix like this. Right? Here, this matrix is same as this matrix because both matrices are having the same value in every places. So this is usually coming from products, right? Later, maybe in mathematics or statistics, you will learn when you come with a product. Suppose, let's say, number of treatments and number of blocks, right? Each treatment having same number of blocks or same number of replicates, right? When you multiply, usually that kind of makes an incident matrix, right? Incident matrix, and from the transpose of incident matrix become as a concordant matrix. That will give you how many times the same treatment has been repeated or same thing has been repeated, right? So normally that is how we define it, incident matrix or concordant matrix. But for the matrix with only one value, I'm not sure any names are there for that, right? If I come across, I will let you know. Right. What is the use of this incident matrix and determinant? What is the use of determinant? So the use of determinant, by using determinant, we can solve linear equation. We can solve linear equation. Right? Can solve linear equation. So this is basically called as Cramer's rule. This is called as Cramer's rule. What does this Cramer's rule says? For example, let's say 2x plus 4y is equal 9. Right? So, right? Similarly, 3x plus 8y is equal 20. As an example. How to solve this equation? These are linear equations. Linear equation 1, linear equation 2. How to solve it? So here we can use the determinant concept. determinant concept to solve the linear equation, right? Okay. So how to solve the equation? For example, in this case, if it is a two linear equation, how many unknowns are there? How many unknowns are there here?
Two.
Two, x and y. Two unknowns, two linear equations, so that we can substitute and solve. Otherwise, we can have we can use the determinant to find out the value for the x and okay, right? So how to take this step forward? For example, let's say look at this equation. So the coefficients can be used as the elements for the matrices. For example, here this is the matrix. Give me a second. Yeah, that has one. Give me a second. I will take a equation. Right, to take equation, right? Let's say 3x minus 5 minus 5 is equal 0. This is one equation. Another equation, 2x plus 3y minus 7 is equal 0. Okay, two equations are there. Linear equation. We can solve it using, I will start from very basic. So we can use the matrix. So we can bring it in terms of x and y equal the values. Let's say from this is first equation, this is a second equation. We can take 3x minus 5 equal 5. That is the first equation. Same thing. 2x plus 3y equal. That is your second equation, right? We'll work with these two equations, right? We can form the matrices using this equation. Look at the coefficient values. They are the ones going to make the matrices. So the general matrices, we could write it as, what is the coefficient of x? That is 3 minus, what is the coefficient? I mean, take the first equation. What is the coefficient of y, which is -1? Okay, right? Here we don't say it, just -1, right? And equal 5. Okay. Then the coefficient of the second equation, 2, 3, which are plus, so that I will write it as. So this is the values already that we have, right? So here we want to find out the determinant of matrix, general matrix D, determinant, I will simply say it as D. That is actually the matrix of finding the determinant 3 minus 1, 2, and 3. Determinant of dx is considered as the x values will be replaced by the equal value. For example, these are the x value. So that will be replaced by, right, 5, 7, minus 1, 3. dy is replaced by, this 3 and 2 will be remaining. Minus 1 and 3 will be replaced by 5 and 7. So these are the, you will have to find out the determinants of those. Right? The value for x is given as determinant of x divided by the determinant of d. Right? Okay. Similarly, the value of y is given as determinant of y divided by determinant. Okay. So can you find out these values, these 3 values? Determinant of d, determinant of dx, determinant of dy. Can you find out the values? What is d? Determinant of d, determinant of dx, determinant of dy. Yeah. Yeah.
So how to write a determinant of x?
Determinant of x is already there.
I didn't understand. So how can you explain again?
So this is the coefficient of x, isn't it? Coefficient of x. You
Yes.
look at it in the equation. Look at the equation. 3 and 2 are the coefficient of x, isn't it? This is x, this is y. If you look at the column wise, isn't it? This is x column, this is y column. Okay. Is it clear? So this is based on the coefficients. These matrices have been formed based on the coefficients. Matrices have been formed based on the coefficients. So we work with the coefficients. So these coefficients are x coefficients. This is 3 and 2. These coefficients are belongs to y. That is here -1 and +3. Right? Okay. Can you get the value here? This is dx is, we will look for d. D is 9 plus 2. 9 plus 2 is 11, isn't it? 9 plus 2 is 11.
Y is 1, X is 2.
Huh? Yeah. No, first get the values here. Then we will solve it later. What is the determinant?
dx 22 determinant.
Huh?
Determinant
dx
of x 22.
22.
22.
Determinant of y?
11.
Huh?
11.
11.
11.
Do you all agree or do you need any other explanation? Because I didn't come to the value of x and y. So look at this equation. From this equation, this is how we formulate the equation, right? From this, we should be able to write the coefficient 3, 2, -1, 3. This is for x, this is for y. Do you all agree?
Yes, sir.
Then we have equal value for first equation 5, second equation 7. So only we use these elements. This is not the matrix, but these are the elements. Is it clear? That is your first step. That to identify the coefficients. Is it clear?
Yes, sir.
Right. Second step, we want to find out determinants. First, we'll have to find out the common determinant to everyone. So that is basically the determinant of 3 minus 1. It includes the variables coefficients 2 and if you find the determinant of that, that is the common determinant. Then we'll have to find out the determinant for each variable separately. When you find the determinant for x variable, here I am indicating x variable, this constant will substitute this column. So now you find the determinant as 5, 7, -1, 3. Okay. For the finding out the determinant of y column will be substituted by this common term, constant values, right? So this 3 and 2 will remain. Then it will be, -1 and 3 will be replaced by 5 and 7. Is it clear?
Yes, sir. Thank you.
That is the first step. Then you have the formula. That is the formula that you have, right? To find out the x value, it is the determinant of dx divided by determinant of d. To find out the y value, determinant of y divided by determinant of d. Clear? So here we could see our values are 11, where the x value is 22 divided by 11. The y value is 11 divided by 11. So x is equal to y is equal to 1. So if it is a two unknown variable, two equation, we can do it by substitution easily. You don't need Cramer's rule. If you want, you can use the Cramer's rule. If it is a situation like this, right? 3x plus 4y plus 2z equal 8, right? 2x plus 3y plus z equal 5, right? Then 4x plus 4y plus 8z equal 15 as an example. Now, this is a big one. So here, if you apply the Cramer's rule, my coefficient for x is 3, 2, 4. Coefficient for y is 4, 3, 4. Coefficient for z is 2, 1, 8. Then we have the constants 8, 5, and 15. So using this, we can have several determinants. How many unknowns are there?
3.
3, x, y, z. So the determinant for all the denominator is the common one, right? So that is d. When you say dx, anyone? What is the determinant for dx?
8, 5, 18.
Huh?
8,
Yeah.
5, 18.
Mm-hmm.
4, 3, 4.
Yeah. First column is replaced by the constant 4, 3, 4. The last column 2, 1, 8. Similarly for dy, so the dy is equal 3, 2, 4, 8, 5, 15, 2, 1, 8. Similarly, dz is equal 3, 2, 4, 4, 3, 4, and 8, 5, 15. Can you find out the derivative of all these four matrices? Can you find out the derivative of all these four matrices? Anybody got the answers?
dx 10.
Yeah.
dy minus 1.
Okay. We can do it together. I will come back. Yes. I mean, give me the determinants. Determinants of d, determinants of dx, determinant of dy, and determinant of dz. What are those values? Is that Karmalita? Karmalita. What is your name? Huh?
Carmelita. Carmelita.
Carmelita. Yes. Give me these values. That is more helpful.
Okay.
Anyone? Right. I will give you a very brief because I just got some directions. So I will give you the formulas. Then you don't forget it. Right? I will give you for a 3 into 3 equation. Right? 3 into 3 equation. Let's say a1x plus b1y plus c1z equal d1. So this a, b, c are constants or coefficients, right? Then a2 x plus b2y plus c2 z equal d2. Similarly, a3x plus b3y plus c3z equal d3. Is it clear? So a, b, c are coefficients. These numbers, values. So this is how the equation. How many unknowns are there? This is one unknown. This is another unknown. This is another unknown. 3 unknowns are there, right? So by using these 3 unknowns, we could write this as in a matrix form. Let's say A1, B1, C1, A2, B2, C2, A3, B3, C3 into a vector, column vector x, y, z equal d1, d2, d3. Is it understandable? For example, here, when you multiply first row and the column here, that become as a1x plus b1y plus c1z equal d1. Isn't it? Okay, we can write it like this. All right. So now, if I want to find out 3 matrices, as I said, right? So here I would like to replace the values, right? suppose, let's say, using another color, D, the determinant of D is based on A1, B1, C1, A2, B2, C2, A3, B3, C3. Similarly, the determinant of X, where the X column will be, X column is the first column here, right? Will be substituted by D values, right? So we would say the D1, D2, D3, and the remaining B1, B2, B3, C1, C2, C2. That will remain there. Similarly, dy is equal determinant of dy. This is A1, A2, A3 will be replaced by D1, D2, D3, C1, C2, C3 will remain as it is. The last one, dz, the determinant of dz will be written as A1, A2, A3, B1, B2, B3, D1, D2, D3. So this is for your additional notes, right? Without making it confused. So you can find out this, right? Now we can find out my X value. That is, the denominator is always a D. Numerator is dx, determinant of dx. Y value will be determinant of dy divided by determinant of z value will be determinant of dz divided by determinant of. Any questions? Yes, now we can go back to our previous question. Hope everyone can understand this. If you need any further clarification, because this is in a formula, so that you can ask. This is what the Cramer's rule says. We can go back to our example. So what is the value for this determinants of each component? Anybody? Carmelita? Yes.
dy is -1.
Determinant,
dx 10. dz 67.
I don't know the values, so I just gave some. What is the determinant of D? Anyone getting a similar answer?
It's 52, sir.
52.
Yes.
All right. How about the others? Dx, dy, dz.
D is 4.
Hmm?
Dx 10.
I'm asking determinant. Now, dz,
dz is 3.
3. Determinant of dz, huh?
Oh,
Who else getting 3? Because
Yes,
you are
sir.
asking me to repeat
Yes,
it. I mean, we'll have to do it again. Shall we?
Please,
Huh? This
D
is
sir.
3.
Yeah,
Huh?
D4. Determinant D4, not 52.
Once again, D, determinant
D,
of D.
not 52, 4.
Oh,
You see how different the values are.
now it's right, sir.
Now it's right. How much sure that this is correct?
Because I found that dx over d and then I replaced in the equation and I checked that is,
That is correct.
yes, sir, that's right.
Okay, right. We believe on you, right? So now this is the determinants. Now we'll have to find out the values. X is equal 10 by 4. Y is equal minus 1 by 4. Z equal 3 by 6. So this is the answers. If you want to cross check, you can substitute on one particular equation and see whether it is satisfying the condition. Otherwise, not. So that is the use of determinant. All right, the use of determinant. Any questions? I have another example. You can try this. This is another example. X plus y plus z equals 6. Y plus 3z equals 11. Right? X plus z, sorry. X minus 2y plus z equals 0. First, you develop your matrices, D matrices. First, you have your D matrix, D, dx matrix, dy matrix, dz matrix. Develop that matrix. That is the first thing. You develop the matrices and tell me the values. Tell me the matrices. What is the D matrix? Tell me row wise. Yeah.
One, 0, 1,
Tell me row wise. Row wise.
1, 1, 1,
1, 1, 1, 0, 0, 3,
Wait. Yeah, 1, 1, 1.
0, 0, 3, 1,
Mm.
minus 2, 1.
Check it whether it is correct.
1, 1, 1, 1,
One,
1, 0, 1, 3.
0, 1, 3. Second row.
Correct now? Right. Now dx. You can tell column wise now. Dx column wise.
6, 1, 1.
6, 11, 0.
Oh, 6.
Column wise. Then
1, 1, minus 2.
uh,
1, 3, 1.
okay. Dy column wise.
one, 0, 1,
Hmm?
1, 0, 1, 6, 11, 0,
101. Okay. 6 11.
11, 0,
Hmm.
1, 3, 1,
Okay. The last one.
1, 0, 1,
Mhm.
1, 1, minus 2,
Mhm.
6, 11, 0.
6 11 0. Right. Now you have the matrix. Matrix of four matrix. Right. Now we'll have to carry out. We'll have to find out the determinants. Find out the determinants now. Everyone, work it out. Determinant of d, determinant of dx, determinant of dy, and determinant of dz.
So can we use this rule for the equations comes like 3x squared plus like that?
I didn't get it.
Can we use this rule for the equations comes like 3x squared plus like that?
Yeah, any equation.
Okay.
But we find out the variables, yes. Right? Linear equation, huh? You said 3x square. X square is not a linear equation, huh? So let's be careful. This is for linear equation. You add, not the multiply. Because two components cannot be multiplied. X square not a problem, right? But for others, yes. Find out the determinant of all these four matrices. Anybody found the answers? Anybody got the answer? I'm waiting for your answers. Huh?
D10,
Huh?
D10,
Okay.
DX53,
DX53.
DY4,
4
DZ minus 27.
minus 20. Okay. Anyone getting a similar answer?
D6 dx minus 9.
Anyone else? Anyone getting a similar answer? It's a worked example. I'm not getting correct answer as you all said. What is yeah?
D equals 9.
What is the determinant of D?
9.
Okay, at least one correct answer. What is the determinant of dx?
9.
3.
9.
9.
I don't hear.
9.
9. That is also correct.
18.
By 80.
dy is 18.
That is 27.
Last one,
27.
minus or plus?
Plus.
Plus. Yeah, this is correct. It's a worked example. That is right. So that means something wrong with your calculation. Be careful when it comes to examination. By looking at the notes, you cannot do the calculation. Note will give you the guide. This is how you have to know. When you multiply, adding, you make mistakes. You have to do it very carefully. So we could say the value of x is 9 by 9. Value of y is 18 by 9. Value of z is 27 by 9. So this is equal 1. This is equal 2. This is equal 3. Okay. So what is the problem in the Cramer's rule? Problem.
Can be used only for linear equation.
Can be used only for the
Linear equation.
linear equation. That is okay. Even within the linear equation, there are some limitations. Even within the linear equation, there are some limitations. What are those? Look at this. Look at this. What is the problem? I just put it as it is to expand it. What is the D matrix? What is the D matrix? Anyone? What is the D matrix? As an example, huh? What is the D matrix? What are the elements in the D matrix?
1, 2, 3.
1, 4, 3.
1, 2, 3 row wise.
Row wise.
Okay.
4, 5, 6,
6.
7, 8, 9.
Right. What is the problem here? We came across a similar one earlier.
Determine zeros.
Determinant is 0. What will happen? For example, dx, determinant of dx is equal 10. Determinant of d is 0. So the value for x is equal 10 divided by 0. What is the problem? Undefined, isn't it? We can't have x is infinity. Can we talk about the x is infinity? Yes or no? We already learned under the limits, isn't it? So this is the one of the biggest problem with the not only for D, even for other cases. Actually, this could be two solutions. Maybe there may be one solution. There may be no solution. We cannot solve the equation. This linear equations, we cannot solve it. That is possible. But by having this value, we cannot. We are not sure whether we can solve it or not. In reality, there may be two outcomes. We can solve it or not solve it. Right? So this is one of the throwback in the this Cramer's rule, because determinant time could be 0, isn't it? Right. Any questions? We have some more items to cover. Like we will be doing it by last class. We need to have some material for last class also. We will learn some more little on matrix for about 2.5 hours in the last class with quiz, right? Maybe give me a second. I would like to upload the quiz marks to you all. Don't write anything. I mean, don't make it make differences. I mean, anyhow, this file is not going to be. I'm not going to take it up again. So this, have you all received the quiz marks in the chat box? It is in the chat box. Have you?
Not yet, sir.
It can't be. No, so I have already sent it. Let's see now.
No.
No, sir.
No, sir.
Yes or no?
No, sir.
No.
No.
It can't, because it is in the chat box. It has. I have received a message.
So did you send to PGIA or to all?
Wait. Somebody has. Yeah. It has been sent to only one person, because he's writing all the time. Wait. Give me a second. Now, check it now.
Yes,
Good.
I did it.
That is for last week, all the quizzes, that you have marked. So if you want, you can, because today I'm going to quit a little early after giving the quiz. So if you want, you can download it and keep it with you. So these are quiz marks from last 5 quizzes, just to have a look. Right? Right, because some have only name, some have only PGI registration number, some has only ID number. It's a mess. Right. Anyhow, we are going to have the quiz number. We'll convert it. Uh, Today, we're going to have the quiz, right? Those who have submitted only the quiz marks are there. Because as I said, the people who have sent by email, that is not acceptable, right? So the quizzes that has been sent to chat box will be marked, nothing else. So I don't know what is the reason, because I have the evidence with the chat box, right? Printouts are there. So if you come personally, we can find it out. Right, anyone has some dispute, you can come personally and clarify the quiz marks, right? Because we take the marks from the chat box, right? As I said last time, whoever send it to my email will not be accepted. Right. Today's quiz is evaluate following integration. Evaluate the following integration. Right. Everyone, don't put anything on chat. By person, you are coming for the exam. You have to come and check it with my document. I have the document, so that we'll have to check it with the document, because sometimes if you send it late, it will not be accepted, right? Because it is a time quiz now. So that is why sometimes some of you might have not answered. So you can check it out, right? Okay, right. Solve the following integration, right? 3x to the power 3 plus 4x square plus 2x. From 2 to 4. So this is the question. Evaluate the following integration. 3x to the power 3 plus 4x square plus 2x. Find out the solution for the following integration. More minutes. Okay, see you on 4th, the last lecture, right? Okay, bye.